we're going to begin this video on adding and subtracting fractions or rational expressions by reminding you that whenever you add or subtract fractions, you need to have a common denominator. And it's important that we start with a problem that we know how to handle already, because if you know how to do it without the algebra, then you just need to transfer the skills over to when you do have the algebra. So I'm going to pretend I'm inside your head right now and talk through what you should be saying to yourself as you do this problem. You should be looking at the 8 and the 5 and going, ooh, I need to have a common denominator to add these two fractions. What do 8 and 5 both go into? And you instantly say, ah, they both go into 40. So you decide to rewrite each of these fractions over 40. Then you say, okay, my denominator has changed. Down below, it's been multiplied by 5. So I need to multiply by 5 up above, and that gives me 35. Now 7/8 and 35/40 are equivalent. Then you look at the second fraction and say, oh, the 5 changed to a 40. That got multiplied by an 8 down below. So up above I'm going to multiply by an 8 in the numerators, and 3 times 8 is going to make 24. Adding across, you keep the common denominator of 40, and then you say, okay, 35 plus 24 is 59, and then you mentally stop and make sure that you can't reduce, that there's nothing that goes into both 40 and 59 before you say, aha, there's my answer. Okay, with that skill in hand, let's move on to the algebra, and it's really important that we work on this common denominator idea. So for the next few problems, we're just going to concentrate on finding least common multiples, which will turn into least common denominators. I want to look at both 5 and 6 and say, okay, least common multiple. 5 and 6 both go into 30. Then I look at the x squared versus x to the 4th, and I choose the larger of the two, x to the 4th. And then y to the 3rd versus y to the 1st, I choose the one with the larger exponent, y to the 3rd. And most teachers and most textbooks just have you stop right there. I like to answer the question, how have these changed, or what have I multiplied by to go from the first expression to this least common multiple? Notice the 5 got multiplied by a 6 to get to the 30. The x squared got multiplied by another x squared to get us to x to the 4th. Likewise over here at the right, 6 times 5 makes the 30. X to the 4th, we had both of those already, but we multiplied by 2 more y's, so y squared. And that idea of answering what have I multiplied by is going to help us in just the same, that's the same question we answered when we said up above, 8 goes into 40 how many times? Oh, 5. Oh, multiply the numerator and denominator by 5. That's the same exact skill that we're concentrating on there. Before we determine what that least common multiple is, we factor each of these expressions separately. For the first one, I can take out a greatest common factor of 3, and the second one factors into the difference of two squares, x plus 2 times x minus 2. Now we need to find a least common multiple that both of these go into. The first one says there needs to be a 3 and an x plus 2 in the least common multiple. The second one says, okay, x plus 2, I can get into that, but I need to have an x minus 2 over there also, so I can get into that. Okay, this first expression, the 3 matches, the x plus 2 matches, it's x minus 2 we've multiplied by. And with this second expression, the both parentheses we match what we had up above, so it's 3 that we've multiplied by, and going from the expression to the least common multiple. Okay, let's continue on with this next one. First expression, we can factor out of 5 and have left over x minus 2. Second expression, I can factor out of 10 and have left over x plus 3. So I need a least common multiple that both 5 and 10 go into. Now since 5 goes into 10, I'm going to choose the 10. X minus 2 and x plus 3 have nothing in common, So I'm going to just write the product of the two of them down here and say that is my least common multiple. The first expression in going to this least common multiple got multiplied by both 2 and x plus 3. The second expression, the 10 was already there, the x plus 3 was already there. It got multiplied by only x minus 2 to get to that least common multiple.